So at this point, we have talked about vertical asymptotes in as much detail as we really need. We looked in the previous video at how to find those, but I want to discuss a little bit more about horizontal asymptotes now. And we're going to look at three different situations. And in order to do this, I'm actually going to do an example for each situation. So let's start off by looking at the function f of x equals 3 over x plus 2. Now, in order to do these examples, I'm going to try to build some intuition and also rely on the definition of asymptotes. At the end of the video, I'll give you a more straightforward rule that you can follow each time if you would prefer not to use your intuition and thought process here. I also rely on the rules as well, but this is just to kind of explain where those rules are coming from. So let's think about what happens as x goes to very large values. We want to figure out what happens to y. So as x goes to infinity, what is y going to go to? As x goes to negative infinity, what number is y going to approach? This is the definition that we're looking at for horizontal asymptotes. Let's think of a really large number for x. So for example, let's go ahead and create a table here. Let's say I put, 1,000 in. That's a pretty large number. In that case, I'm going to end up with 3 over 1,000 plus 2, so 1,002. This is a very small number. Let me put an even larger number in for x. Let's go from 1,000 up to 1,000,000. If I do that, then my y value is going to be 1,000,000, and 2. The 2 is becoming less and less relevant as we get to larger numbers. Let's say I put, 1 trillion, 12 zeros. Then I'm going to get 3 over basically 1 trillion and 2. Now the point I want you to start to make here is that these values are getting very, very close to 0. So as I continue to do this, I'm going to end up with 0.000000003 maybe, and then this will get pushed back further and further. I'll have 0.000000003, etc., etc. And so eventually this will tend towards 0. So, going back to my original question, what number is y tending towards as x gets to very, very large values? And you could plug these into the calculator as well. Eventually your calculator will just tell you that this actually would be 0. So for this function here, we are going to end up with a horizontal asymptote at y equals 0. And we can go ahead and graph that. So let me do, just to confirm this, we could go 3 over, and it was x plus 2. And notice if I go to extreme values of x, so over here to negative infinity, the y value is getting very, very close to the x-axis, very, very close to 0. And so we were correct on that one. Okay, so this was one situation. Let's look at another one. Let's now write g of x. We'll do g of x equals 2x plus 1 over x minus 1. Now in this case, excuse me, if I plug in very, very large values for x, I end up with y will be going to a particular number here. And let's think about what that number might be. So if I do x and then I write g of x here, let's just go straight to 1 trillion. I'm going to have 2 times 1 trillion plus 1. The plus 1 is basically irrelevant because we're already at a trillion. And then I'm also going to have 1 trillion minus 1. The minus 1 is irrelevant at this point because we have a trillion. If you don't believe me, go on to larger numbers. Go on to even larger numbers. If you plug this into the calculator, eventually your calculator will just start spitting out the number 2. So at very, very large values, all we really care about are these first terms here, essentially the leading terms in each polynomial, in the numerator and the denominator. And so in this case, y is going to end up going to the value of 2. So for this one, the horizontal asymptote will be y equals 2. Okay. So that was the second situation. In this case, we had the numerator and the denominator both have an x in them, and so our asymptote was y equals 2. Now the last one is a little bit trickier to come up with the actual horizontal asymptote, I should say, but I'm sort of hesitating because it won't be a horizontal asymptote. Let me just tell you what I'm talking about. So let's look at this one now. Let's do the same thing. Let's think about large values of x. Let's think about what y is going to do. So at very, very large values of x, let's just go straight to a trillion again. I'm going to have 1 trillion squared plus 3 times 1 trillion minus 4 over 1 trillion minus 2. Again, the minus 2 and the minus 4 are pretty irrelevant in this case. But I do have these 1 trillions going on. Now think about a trillion. That's a trillion. Thousands, millions, billions, trillions. If I square this, I end up with this number. I end up with a trillion trillions. Okay. So this is thousands, millions, billions, trillions, quadrillions, quintillion, sextillion, septillion. I believe this is a septillion, but I might be wrong. Now, if you were to look at this plus 3 trillion, which is right here, just like that minus 4 was irrelevant to the trillion, 3 trillion is now irrelevant to this larger number here. So this larger number actually ends up taking over. And so you'll notice, if I go back to my original expression up here, this is actually just going to end up being bigger and bigger and bigger if you plug this into a calculator. It doesn't go to a single number, i.e. infinity, or if you go the other way, it'll be negative infinity. So in this case, we would say that there's actually no horizontal asymptote. In some classes, you'll then talk about a slant asymptote, but I'm not going to be discussing a slant asymptote with you today. So just to kind of conclude this concept here, if you have, what do we have? X squared plus 3x minus 4, plus 3x minus 4 divided by x minus 2. Let's go back to our original window here. Notice as I go to very, very large values of x over here, y continues to increase forever and ever and ever and ever. It actually kind of looks like a line. That's why it's called a slant asymptote. But for now, all you really need to know is that there's no horizontal asymptote. Okay. So we've now seen all three situations. Let me go ahead and summarize those, and then I'm going to end the video because I know this is dragging on a little bit too long here from what I like. So let's go back to horizontal asymptotes. And for this discussion, let's say that you're given some function, r of x, it equals n of x over d of x, just like I said before. Remember, these are polynomials, so we could actually write them as a x to the power of n plus some constant term. I'm going to use a different letter instead of a here. Let's say it's bx to the power of m. We'll just use d here. So the polynomial in the numerator has leading term ax to the n, and its degree is n. The polynomial in the denominator has a leading term of bx to the m, and its degree is m. Okay, so 3 situations to think about. If the degree of the numerator, n, is less than m, this is the very first situation we looked at. The degree of the numerator is 0. The degree of the denominator is 1, so n is less than m. Then the horizontal asymptote is y equals 0. If, on the other hand, they're equal, then the horizontal asymptote is y equals whatever a over b is equal to. And finally, if it's the last situation, then we just say there's no horizontal asymptote, and instead it would be a slant asymptote. And that concludes this video. I do apologize for it running a bit long. We'll see a